There is a powder that costs $5 at any auto parts store that eliminates brake squealing permanently, not reduces it slightly, eliminates it. That high-pitched screech that makes everyone in the parking lot turn and stare every time you touch the brake pedal, the embarrassing squeal at stoplights that makes passengers wince, the ear-piercing metallic shriek that mechanics use to justify charging $200 for complete brake service. One application of this anti-seize compound stops the vibration at the molecular level and silences brakes instantly. Professional mechanics charge nothing to explain this, because explaining it would eliminate their most reliable upsell category. A tube of copper paste sitting on the parts store shelf for $5 cannot justify diagnostic fees, brake pad replacement recommendations, and labor charges totaling $300. This is the story of the brake quiet compound that stops the noise and the service industry that built an empire on unnecessary pad replacements. Welcome to my channel. If you are not subscribed yet, hit subscribe and the bell. This is where we reveal what the automotive repair industry spent decades concealing. Now here is where this problem was engineered. In 1949, Chrysler Corporation introduced the first mass-produced disc brake system on the Crown Imperial luxury sedan. Disc brakes were revolutionary, providing dramatically superior stopping power compared to the drum brakes that dominated automotive design since the early 1900s. But disc brakes introduced an acoustic problem that drum brakes rarely exhibited. When a brake pad contacts a spinning rotor, friction converts kinetic energy into heat, slowing the vehicle. That same friction also generates vibration at frequencies between 1,000 and 16,000 Hz. When vibration frequency falls within the range of human hearing, typically 2,000 to 8,000 Hz, we perceive it as the distinctive high-pitched squeal everyone recognizes. The engineering challenge was understood immediately. Brake manufacturers experimented with pad compounds, rotor designs, and caliper configurations throughout the 1950s and 1960s. They discovered that brake squeal results from stick-slip friction, a phenomenon where the brake pad alternately grabs and releases the rotor surface thousands of times per second. This rapid oscillation creates acoustic vibration that resonates through the metal components. The brake rotor acts as a speaker cone, amplifying the vibration into audible noise that can exceed 90 decibels at close range. The science behind brake squeal is documented in mechanical engineering journals since the 1960s. The frequency and intensity of squeal depend on multiple factors including pad composition, rotor surface condition, caliper rigidity, temperature, and humidity. But the fundamental cause remains consistent across all disc brake systems. Vibration occurs when friction coefficient varies during the braking cycle. As the pad contacts the rotor, initial friction is high. Microscopic surface asperities on the pad and rotor interlock momentarily, then break free. This stick-slip cycle repeats continuously, generating vibration waves that travel through the brake assembly. Manufacturers addressed squeal through multiple engineering solutions. They added shims between the pad backing plate and the caliper piston to dampen vibration. They chamfered pad edges to change contact geometry. They formulated pad compounds with friction modifiers to smooth the stick-slip transition. But the most effective solution used universally in automotive manufacturing since the 1970s is applying anti-vibration compound to the back of the brake pad. This compound, typically containing copper, ceramic, or molybdenum particles suspended in a synthetic grease base, serves a critical function. It fills microscopic gaps between the pad backing plate and the caliper piston, creating a continuous contact surface that prevents vibration transmission. When vibration cannot travel from the pad through the caliper to the larger brake assembly, the resonance frequency drops below audible range. The braking force remains identical, but the noise disappears completely. This is not theory. This is standard assembly procedure in every automotive factory worldwide. Brake pads arrive pre-lubricated with anti-seize compound on the backing plate. During installation, technicians apply additional compound to ensure complete coverage. The compound costs manufacturers approximately 15 cents per brake job in bulk quantities. A 2012 study conducted by the Society of Automotive Engineers tested brake squeal suppression methods on 80 vehicles across 12 manufacturers. Researchers induced squeal by installing brake pads without anti-vibration compound, then measured noise levels during controlled braking from 30 miles per hour. Every vehicle exhibited squeal exceeding 85 decibels. Researchers then applied copper-based anti-seize compound to the pad backing plates and repeated the test. Squeal disappeared entirely in 94% of vehicles. The remaining 6% showed squeal reduction below 40 decibels, considered negligible background noise. The compound eliminated vibration transmission without affecting braking performance, pedal feel, or stopping distance. The automotive brake service industry generates over $14 billion annually in the United States. Brake pad replacement accounts for approximately 40% of that revenue. Service advisors are trained to recommend pad replacement whenever customers report brake noise. The standard pitch emphasizes safety, suggesting that squealing brakes indicate worn pads requiring immediate replacement. In reality, brake squeal has zero correlation with pad wear. New pads squeal, half-worn pads squeal. Pads with 90% material remaining squeal. Squeal indicates vibration frequency, not safety risk. Shops charge between $150 and $300 for brake pad replacement depending on vehicle type and whether rotors require resurfacing. The actual pad cost ranges from $25 to $60 for a complete axle set. Labor time is 45 minutes to 1 hour for an experienced technician. But the most profitable aspect is the diagnostic fee. When customers complain about brake noise, shops charge $80 to $120 for inspection before recommending service. If the customer understands that a $5 tube of anti-seize compound eliminates squeal in 10 minutes, the entire revenue stream collapses. Dealerships and independent shops responded predictably. They never mention anti-seize compound as a solution. Service menus list brake pad replacement, rotor resurfacing, and caliper service. When customers specifically ask about brake noise solutions, advisors mention brake quiet spray, an aerosol product sold at retail for $12 to $18. This spray contains the identical copper or ceramic particles found in anti-seize paste, but in a volatile solvent carrier that evaporates after application. The spray works temporarily, lasting 2 to 4 weeks before squeal returns. This creates recurring visits and recurring revenue. The paste formulation lasts indefinitely because the particles remain embedded in the grease base, continuously dampening vibration. Here is exactly what they will never tell you. Eliminating brake squeal requires no pad replacement, no rotor service, no special tools. Jack up the vehicle and remove the wheel. The brake caliper is visible behind the wheel hub. Remove the caliper by loosening 2 bolts that hold it to the bracket. The caliper slides off, exposing the brake pads. Do not disconnect the rubber brake line. Let the caliper hang supported by the suspension. Remove the brake pads from the caliper bracket by sliding them out. You will see the metal backing plate on the rear of each pad. Buy a tube of copper or ceramic anti-seize compound from any auto parts store. Brands like Permatex, CRC, and Loctite all work identically. The tube costs between $5 and $8. Apply a thin, even layer of compound to the entire backing plate surface using your finger or a disposable brush. Cover the metal completely, but avoid excessive thickness. A layer approximately 1 mm thick provides optimal vibration dampening. Do not apply compound to the friction material side of the pad that contacts the rotor. That surface must remain clean. Reinstall the pads in the caliper bracket. Slide the caliper back over the pads and tighten the mounting bolts. Reinstall the wheel and lower the vehicle. Pump the brake pedal several times to reseat the pads against the rotor before driving. The squeal will be gone immediately. The compound does not wear off, does not wash out in rain, and does not degrade from heat. Reapplication is unnecessary unless you replace the brake pads years later. A delivery driver in Chicago documented this procedure on a 2016 Ford Transit van with severe brake squeal that had persisted for 8 months. The dealership had quoted $280 for front brake pad replacement. He declined and applied anti-seize compound himself using a $6 tube from AutoZone. The squeal disappeared instantly. 18 months and 45,000 miles later, he posted an update. Zero squeal had returned. The original brake pads still had 60% material remaining, confirming the squeal was never related to pad wear. Knowledge like this does not disappear because it stops working. It disappears because it stops generating profit. Subscribe and share this with every driver still paying mechanics $200 for what a $5 tube solves.